Here we are, Unit 2A, Lesson 1, so 1.1, 2A.1.1, I should say. That 2A is going to throw us off, isn't it? Alright, so we're taking a look now, and we're going to identify a few things with these polynomial relationships. So the first thing, we want to talk about what are the terms of each expression, the coefficient, the variable, and the power of each term. Okay? So, if we're taking a look at this, we've got two terms right here, right? Y to the fourth and 13. Okay? So our terms would be y to the fourth and 13. So we have two terms. Okay? So now, do we have any coefficients? Remember, a coefficient is the number multiplied by a variable. So we could say that 1 here is our coefficient because it's technically 1y to the fourth. But we really don't need to say that. Okay? The variable, obviously, is y. Okay? Oh, I probably should have done that in red, huh? And the power of each term. Okay? So it's y to the fourth, so our power would be to the fourth. Okay, for 13, what would our power be here? You may say there is no power, but it would be to the first power. Remember, 13 to the first is 13. Anything to the first power is itself. Okay? So that's kind of what we're doing on all of these. So let's take a look at number 2. We have 8c cubed minus c squared plus 8c. So we have three terms. So we've got 8c cubed, negative 1c squared, because it's minus c squared, and 8c. So those are our three terms, right? So our coefficient would be 8, negative 1, and 8, because they're the numbers multiplied by it. Our variables, obviously, are c, 3 of them, and the power would be to the third squared and to the first. If there's no power, we automatically assume it's to the first. Okay? So 3, we've got 12z to the fifth plus 9z squared minus z minus 7. So our terms, we've got 12z to the fifth, we've got 9z squared, negative 1z, and negative 7. So we've got four terms here. Now, we've got a couple of coefficients, right? 12, 9, negative 1, not negative 7 because there's no variable to it. Though technically, we could call this c to the 0. If we really wanted to get crazy, because remember, anything to the 0 is 1. But we typically don't try to make too much work for ourselves, so we'll just leave it as the constant. Okay? Variable is z on all three of those ones. And then their powers, 5, 2, and 1. And if we really wanted to, we could say 1 on that one as well. Alright, now the last one, negative 5m to the 10th plus m to the 8th plus 5m to the 6th minus m to the 4th. So we split it up. We've got these four terms, negative 5m to the 10th, m to the 8th, we could call that 1m to the 8th, 5m to the 6th, and negative 1m to the 4th. So our coefficient, negative 5, 1, 5, and negative 1. Our variable is m on all of them. And then our exponent, our power, is 10, 8, 6, and 4. Okay. So now, on the next three, it says write a polynomial function using the given terms. Determine the degrees of each polynomial function. So remember, when we're writing a function, a polynomial function, we always start with the highest power. And that power, we also call it a degree. So if I look at 5, x to the 8th is our highest power. So that's the degree of our polynomial. The highest power is its degree. So I could just write degree and put 8 here. Okay, so now what are we going to do? Well, we've got negative 3x cubed. So negative 3 we can just write as minus 3x cubed. Okay, and then the last one would be a positive 30x. So there's my polynomial function. And I suppose if I were to really make it a function, I should probably go f of x equals to be official. Okay? So let's do the next one. Let's call this one g of x to make it a function. So what's our highest power? Be negative x to the 6th. So what would be our degree? Our degree would be 6 because that's our highest power. So now we move on down the line. So our next one is negative 6x cubed, then positive 14x squared, and finally the constant, positive 10. So there's our polynomial function with a degree of 6. And make sure you recognize these degrees. They will come in handy later on when we're dealing with graphing. So very important that you do that. Let's call our next one h of x. So we look at the highest power. There's 5, 7, 3, 1, and 0. So it would be x to the 7th. Okay. So our degree here would be a 7th degree polynomial. Okay. Next up would be negative x to the 5th, then 7x cubed. Don't confuse the coefficients with the degrees. Then 2x, and finally 22. So there we go on those ones, guys. Okay. Now these last couple, it says each of the figures below is divided into separate parts with each area written within that part. So here's our areas. Okay. The area of the cube would be 9x, or cube square would be 9x squared. The area of the triangle is 12x. Okay. It says find the total area of each figure. All units are in square inches. So when we have areas of two separate things, to get the area of the whole thing, we simply add them. So we get 9x squared plus 12x. Can we simplify that? No, but that's what our area would be if we knew what x was. Okay. Then number 9, we just add all these ones together, right? So start with your highest degree. Now you could just go 5x plus 3x squared plus 8, but we would prefer to rearrange those, so you might as well start off, and you should just get in the habit of doing this, starting off with your highest degree. So whenever you have to write a polynomial, start with your highest degree, then go down to your lowest degree. And that constant should always be last. Because like we said, technically, that's our lowest degree, 8x to the 0, even though we don't like to put it in. Okay, now the last one, we add these four together. So look for that highest degree, write that one first, then go to the next, then the next, and finally the last. And there we go, guys. Pretty simple, right? Not too bad there.